Alrighty, keep in mind you get quiz coming up tomorrow. Quiz covers 4-3, 4-4, and 4-5. Just to kind of break those down, 4-3 is multiplying and dividing. So this is actually technically a division problem here. Multiplying and dividing rationals, that is. And then 4-4 is adding and subtracting rationals. That's where you need the common denominator. And then 4-5 is solving rational equations, which you can do a few different ways, but generally getting the common denominator and canceling it out is kind of the best route for those. So anyway, this is a fraction divided by a fraction. And so what we're going to do here to solve this, anytime you're a fraction divided by a fraction, you want to change to a multiplication problem and invert it. So I would rewrite this as x minus 1 over 4x times, and then just go ahead and flip this over. So it's going to be 2x over, and then since this is the only part that wasn't already factored, I'm going to go ahead and take out the GCF. So I'm going to rewrite that as x times x minus 1. And once you do this, you can think of it as really just one big fraction, because we're just multiplying things. You get all these different quantities getting multiplied. And at this point, we can look at it and see, all right, what can we reduce? Is there any things that we can eliminate, cancel out, reduce, etc.? So x minus 1 over x minus 1, okay? And x divided by an x. And then also, this 2/4 we can reduce to 1/2. So when we go to write our kind of final simplified answer here, the only thing on top is going to be 1. So I'm going to reduce this to 1/2. And then the only thing left down here is just the x. So it's actually just going to be 1 over 2x. The other piece we need is our restrictions. So anything that's ever been in a denominator. So x can't be 1. It can't be 0, 0, 0. So yeah, that takes care of everything that was ever in a denominator. The only thing it really never is this piece. So those would be our restrictions. If you're curious on checking these, you can by graphing. I'm going to type in the calculator and I'll show you what I'm talking about. Okay, so if you want to check this with a graph or decimals with the table, whatever you want to do, you can type these in. If you type in this, which is very tedious to type in, and you type in this, the table should be identical for the most part. The only thing is this one's not going to know about these restrictions, but we'll talk about that. So I did type these in. So this first one, you got to go kind of parenthesis crazy. So I mean, if you want to take a look at it, you want to see what you need to look at to put it in there, that is it. Because you need to make sure it does this, and then it does this, and then it divides those two things. So personally, I think it's best to just know what you're doing and not need to check this, but you can check it just to keep that in mind. And then the one answer I got was the 1 over 2x. I like the table for checking this. And what I look for is just to see, am I getting the same values on everything? At 3, at 4, at 5, at 6, I'm getting all the same values. You will notice that at any of your restricted values, the one equation won't have an error because this simplified problem doesn't know it has a restriction. That's why the calculator doesn't know where this came from. That's why you can actually get a number there. But at 0, you get errors for both because this one would still have 0. Okay, sorry, I got a call in there, but I think we're good there. So again, just a way to check it if you want to. But again, if you know you're doing the right stuff, then you've done it right. You don't need to check it, but it's just something to have nice in your back pocket there. All right, so then the last problem here is find the LCM, the least common multiple. And the key there is you really need these in factored form. So you can see if they have anything in common that you can, basically reuse. So this one would factor to, looks like we use -7 and 2. So x minus 7, x plus 2. This one would factor to x plus 2, x plus 2. All right, so in terms of our LCM, what we need here is what would the common denominator be? Like, what would we need to make the common denominator if these were the two things in the denominator? And so basically you'd look at it and be like, well, they both have an x plus 2, but this one needs another x plus 2, and then this one's going to need an x minus 7. So our LCM really is just going to be x minus 7, x plus 2, x plus 2. Essentially, you need every unique factor here. So you need an x minus 7, and then you have to have at least 2x plus 2s because this one has 2x plus 2s. So that's it. So that's what an LCM is. It's the concept of thinking of if these were in your denominators, what would that common denominator need to become? All righty. Good luck with that review, and we'll be quizzing tomorrow.